All right, Chan Physics. I forgot that my video will only let me do 15 minutes. So now we're going to do this real short one with 6 through 10, and I'll even include 11 because I saw that in this Moises thing. All right, so this is one with the Lamborghini, and so we're right here, and it talks about the car accelerating at a rate of 8.5 meters per second squared. Right there, when we see meters per second squared, we know acceleration, right? Because nothing has that unit. It says it starts from rest. Rest means velocity of 0, and it reaches a speed of 35. And then asks how far does it travel? That's our x, right? So right now, right away, as soon as we know distance is involved, we know we have to choose between these two. We have an initial velocity and a final velocity. So that's giving us a good question, a good indication that this is the equation that we need to use. And then we can look here and there's no time. And so we could not use this equation right here because there is no time, right? And so it's obvious from all of the list tells us we need this equation. All right, so the math is a little hard. The final velocity is 35, so 35 squared. The initial velocity is 0 squared, plus 2 times 8.5, which is the acceleration, times delta x. So that's what I get when I'm just in the middle of just substituting in. I just get that. And so now the question becomes, how do I get delta x by itself? And to get delta x by itself, I've got to get rid of the 2 and the 8.5. And so all I'm going to do is divide by that, right? The 0 squared is going to drop out, and so I'm going to get delta x by itself on this side. Okay, when I look at the left side, well, I've got 35 squared. Whatever I've done to one side, I have to do to the other side, so I'm going to have to divide by 2.85 on this side, or 2 times 8.5, and I'm going to get this number right here. And so my delta x here, 72.05. Hold on one second. Okay, hopefully not a big problem there with me jumping in and out to talk to a teacher, but now we're going to go on to number 7. This is the one that with the airplane flying and they want to slow down. And so when we look at this problem and we just do the list, we get a equals negative 2.1, t equals 12, final velocity is 30, and the initial velocity is what they're asking us to find. We put our finger right there. We know that we're going to get a, t, vi, and we go, okay, wait a second. It's not one of the two that have distance. It's not the 3, so I just have to choose between this one. And if you're never sure, always pick the flat one because that one doesn't have anything in the denominator and it makes the algebra much easier. Okay, so now I'm going to plug in the numbers. VF is 30, that's what they gave us. VI was the one they're asking us to find. Plus negative 2.1 is the acceleration, so that, and then 12. So I'm going to take a little, just another second here just to draw something in here, just so that you see this. Whenever we're doing algebra, the first step is always to try to make things easier on ourselves. So if I was to rewrite this, and let me put it in green, I took a shortcut. And what I would have done if I was in your situation, I would have wrote down 30 equals VI plus, and I would say to myself, what's 2.1 times 12, or what's negative 2.1 times 12? And I think it's 25.2, but I'll just put it in there real quick. Yeah. And so I get plus a negative 25.2. All right. So that's all I did was put this, and I put this in my calculator, and I did this. So now I have to get VI by itself. That's the point of the algebra here. And so I have to get rid of a negative 25.2. How do I do that? Well, I do the opposite, right? I add 25.2. So if I add 25.2 to the side, I just get VI by itself. I have to add 25.2 to the other side because whatever you do to one side, you do to the other. And I get VI equals 55.2. And I write that down. And I see that I made a mistake even, right? Because it's just meters per second. And I say to myself, does this make sense? And so I go back to the question. It says, an airplane is flying, but the pilot wants to slow down. So I have an initial velocity of 55.2. I have a final velocity of 30. I have a number that's faster, and then that makes sense, right? Because the number, they should have been able to slow down from this number to this number it's worthwhile just to think about it for a second and say, okay, yes, I have the right number. Okay, let's go a little bit faster here so we don't run out of time. 8 on my sheet is this one right here. It's a toy car moving at a track, 1.5 meters per second. So that's our velocity. How long does it take? So I was like, how long does it take? That's a time. They're asking me to find a time. And then delta x is 0.18. All right, so I know right away, 3 variables. That's the easy equation, v equals d over t. But when I plug in the numbers, velocity 1.55, d is 0.18, and t is here, I'm back to that problem number 2 that I had where the t is in the bottom. And so you can see this is something that we're stressing, and we really want to teach you guys how to answer this question and make it easy if you're doing it a bunch of times. And so we have to remember that to solve this problem, the first thing we do is multiply by t. If we multiply by t, these two t's cross out, and I get a t over here on the top. So now I've got t times 1.55 equals 0.18. And so I got to get this t by itself now. How do I get it by itself? I get rid of the 1.55 by dividing. Boom. 0.18 divided by 1.55. Can I tell you honestly, and I told my class this numbers are set up on purpose. It is always students, when they look at this, they go, it must be 1.55 divided by 0.18, because you would never take a big number and divide it by into a small number. But that's exactly what it is. And when you think about it, if the car moves at 1.55 meters per second, it's going to cover 0.2 meters, which is just a tiny little bit, very quickly, 0.116 seconds. And so if you did it the other way, where you took this number divided by this number, that you fell for that thing, when you asked yourself, did it make sense, you probably got a number that was, I don't know, about 5, 6, 7, 8 maybe, 8 seconds, and that would not make any sense, right? Because we would say, if it's moving this quickly and it's only this short of a track, it must be only just a fraction of a second, okay? All right, a cheetah is one of the favorite questions. I don't know who wrote this question, maybe 12 years ago. The cheetah, fastest animal, has an acceleration of 9 meters per second squared, starts from rest, so it has to be 0, going to be done at 31, and the time is unknown. Okay, put our finger right there, a, vf, vit, it's not 3, it's 4, it doesn't have distance, so it's probably this equation right here. When we put in the numbers, 31 is the final, plus 0, that's the initial, plus 9t. If I make this easy on myself, I say, well, that 0 is doing nothing, so I rewrite the equation as 31 equals 9t. I just got rid of the 0, right? And now how do I get the t by itself? I got to divide the 9. So I'm going to divide by 9 on both sides, and I'm going to get 3.44. And that one does make sense, right? Because it's going to take about that long to go from 0 to 31 if we're accelerating at 9. All right, last problem. Boat starts at rest and accelerates at 5 meters per second per second. That's my 5 meters per second squared. All right, starts from rest. I've got a velocity of 0. It has an acceleration, right? Put that there. How long does it take the boat to cover this much distance? 22.5. How long does it take? That's a time. So we got to ask for it. So we got a distance, so we have to choose between those other two. We have initial velocity, but not final. So what we need to do is say to ourselves, okay, if we're choosing between these two and we don't have final velocity, we must be using this equation right here. And so I wrote that equation down, and now I'm substituting in. So some of the math is, I went slowly on this one so that you guys could see it. The delta distance is 22.5. 22.5. The initial velocity is 0 times time plus 1/2 times the acceleration of 5 times the time squared. First, 0 times time is 0. Doesn't matter what time is. This entire term right here, and this is going to drop out. And so I rewrote it as this is right there. And I took 1/2 of 5 times is 2.5. So 22.5 equals 2.5 times t squared. Got to remember that, t squared. So how do I get this 2.5? How do we get t by itself? I must divide by 2.5. If I get rid of that 2.5, I must divide by 2.5 here, right? And then I get 9 on this side, and I just get t squared by itself. Didn't ask you to find, though, t squared. I asked you to find t. So I have to take the square root of both sides. Square root of t squared is just t. Square root of 9 is 3. The answer is 3 seconds. All right. Those of you guys who aren't in my class but are in Miss Moise's class who are thinking about question 11, I did see it. Somebody showed it to me. I'd never seen it before. Here's the quick solution for it. Really kind of messy. VI was 0. A was 12.4. VF was 20. Delta X was the question mark. So we have a delta X. We have VF. We have VI. We choose this equation right here. We plug it in. 20 squared for VF. 0 squared, 2 times 12.4 times delta X. The answer I got for that problem, 16.2 or 0.12 meters. Okay. Hopefully this helped you guys if you're watching. If you guys ever watch these and there's a problem, please tell me about them. Okay, bye-bye.